Hi, in this video I am going to go through some examples of conditional logic chains as well as function writing. It's going to be a fairly long one, I think, so feel free to scrub through, but I'm just going to get started. So this first one is pretending that we're making a game. It's not pretending, it's making a game of rock, paper, scissors where the player can change what they write and the computer randomly generates a value. So this is a sample function here. I'm first combining these three character values into a character vector of length 3. I'm then sampling it once in order to generate things like scissor, rock, 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 scissor, 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 rock, scissor. Wow, it's technically, I could go on for a very, very long time without ever seeing paper. It was a 1 in 3 chance, but it took me quite a while to see one. But this is what it's doing. It's just going through and sampling randomly what value to do. Right now, I'm just making the player scissor, although the idea is that this could change. In fact, the real idea is that eventually I would make this into a function where I can just kind of play rock, paper, scissors. So a very simple game. The first section, though, I'm asking you to fill out is what would go here. And if we can look at the context based on what I've already written, it's intended to represent when there's a tie. Now, right now, the player is scissor. And so this is wrong. But I could, in theory, like say is computer scissor. And if so, then print it's a tie. Because that's true for right now. But the problem is what happens when player changes. And so there's a much better strategy, something much more forward thinking, and that's to just check when computer is player. And that is when there's a tie. And this is going to apply for more situations. So this is just really more demonstrating how we can be a bit strategic in how we do this. Now it's 2 equals sign because just one would have overwritten it. I do actually have to run my code. Let's see what I just generated now that I ran the code. It's rock. So this should return false, and it does. The next one is testing if the player is scissor, which is true. Then it's going to do everything between these 2 curly brackets. Now, if you're ever not sure of what like curly brace matches which one, you can put your cursor to the right of it. And depending on your theme, you'll get some highlighting. And this is how you can kind of check. And this is a really important one. We can see that there's like X's and things on my screen right now. It's because it's not like perfectly matched. Now, normally you'd probably want to avoid being so convoluted. Like there's much cleaner ways to write this code, but I mean, I think this is fairly understandable. It just takes a little bit of effort. But let's go inside of here. So we're saying if the player played scissor, well, we already know one thing, is that if we've reached this point and it's not a tie, then that means that the computer did not play scissor. So that means there's 2 other options we should test for. Did the player play, or the computer play rock? That is true. And since that's true, this should get printed, and then the rest of this shouldn't matter. But what if the computer played something else? Well, we've already checked to see if it matched scissor. We've already checked to see if it matched rock. And that means the last check here would be if the computer is paper. And so then we get scissor cuts paper. Ah, how could I lose? And it's very dramatic. And then finally, I have this else. And this else, I think a lot of students overlook, but it's actually a really nice technique. And this is just making sure that, if there wasn't this else, and let's say that I had just made a typo, like what if I had said papers instead of paper, or rocks instead of rocks? Well, if that was true, just nothing would be printed. So I made a mistake. Not the computer, not the player. I made a mistake while coding, but without that else statement, it can be a little bit hard to see. And so that's kind of the point, and I've undone my deletion and I've redone this typo here. But with that else, it catches that something else was occurring, something that I wasn't checking for explicitly. And that allows me to then go back in and do some debugging and just make sure that something's going on. So normally that would actually be like some sort of there would be some sort of like error code that's probably a little bit more specific, especially if it was needed. Okay, so that process is going to repeat for these other ones. These are just going to be different checks. So here I can see that it's when the computer played rock. When the computer played scissor. When the player played rock. And here you would just fill it in with stuff like this. So I mean, I could copy and paste it if I want to, but we can just quickly go through. So if the computer in this situation, well, not rock, because I've already checked for rock when I checked for a tie. So scissor. Else if the computer played paper, and then that's all of the possible options, but I always like to have some sort of like error message. Oh no, I messed up. Oh, something like that. I don't know, some silly message. All right, inside these print, so the rock, the player played rock, the computer played scissors. So that means the computer is going to beat, or sorry, the player is going to beat the rock. Oh no! How could I lose? My precious scissors. So sad. I don't know, something silly. Okay, and then the other one, just again, you know, some message, print message. Ha! I covered your rock. Weird. I always think it's funny. Why does paper make rock? So strange. Finally, we have this last check that is going to be the end of our if, and else chain. This is going to be if. Let's go check this one out. It's not a tie. The player didn't play scissor. The player didn't play paper. The player didn't play rock. So what else could the player have played? Well, something that's not allowed. Something that's not scissor, not paper, or not rock. That's the only option because we've already checked for the rest of it. Now, it could be all sorts of permutations there. It could be rock, like capital. It could be scissors. I constantly make that typo. I saw it a couple of times. It could be a lot of things. So basically, if the player plays anything other than an allowed value, this gets printed. So, I mean, this is one that's very likely to happen. These are only ever going to happen if I've messed up with coding. But this one is going to happen quite often because, well, anytime the player makes a typo, that's going to occur. Now, just to test this out, we can go through maybe each of our different player combinations. Oh, there was a typo somewhere. There we go. We could just keep testing this. Now, I'll be honest, I think if I was really dedicated to testing this very well, I would probably write some sort of loop that would go through each of the different combinations and try them out. I'd review the code. I would just focus on it a little bit harder. In the end, this is fine as it is. Let me just check to make sure that it handles error messages correctly. So I searched for, I said player is going to play papers, plural now. Ah, you fool! You've clearly made a typo. Try again if you dare. So my snarky comment, appropriate for a player who has played a typo. And there we go. Next up, I just have some code here. It turns out that a fairly common problem is doing things like this, or just like accidentally leaving out certain values. And so what this was doing in here was just trying to keep it from, as you experimented, it wouldn't just keep going. This is kind of a common problem. So a lot of my students are taught by prior teachers to highlight the code that they want to run. There is some problems associated with that technique. It's fine, and I understand why your teachers have said that. But what happens is you get these weird situations where I have to. It's a little bit weird because it's kind of hard to get to trigger on purpose. We get to these situations where the function is left incomplete or the code is left incomplete, and you're just like, what's going on? What? And it just keeps accepting it. And what's going on is it's actually waiting for an in curly bracket. In curly bracket, there we go. It was waiting for 2 in this case. But the issue is usually resolved by coming down here, and when you're getting stuck, you just come down here, you press escape. So I click down here a few times, and then I press escape until I get out of the plus symbol. So I exit that incomplete code statement. That's what this was doing. This was helping it keep from just keep looking for another curly brace. All right, so now I am going to write a function named linmod. Okay, that's easy enough. Linmod. It's going to be the function. It's going to have some arguments, and this is now this section right here. It's going to have x, c, m, and b. And then there's going to be some code inside. But before I do that code, I want to practice what I preach here and not start coding inside the function. So this is me just kind of planning things out, making typos, you know, what I do. And I fixed it. And now I'm going to be planning out this code. Now, to be fair, this code is fairly simple. We're just calculating y based off of a simple kind of linear-like model. It is a linear model. It just depends on if those values are constant or not. So assuming they're constant, it's a linear model. So that code will work. If I wasn't confident that it would work, I could make some test data. So I'm going to come above my function to test that, because eventually I'm just going to kind of make all these one thing. But let's make some test data. So, you know, what should you make as test data? Well, you want to kind of make it as simple as possible. You don't want to make a lot of test data because most of it should be calculated by your function. But in this case, I do have several values which need modification. So I'm just going to do something realistic. I'm just going to say like -5 through 5. It's reasonable. For the slope, let's just do 2 because that's some easy math. For C, oh, let's do -1. Let's get a little bit fancy now. And for B, let's do -2 or -3. Just that way we have different values for each thing. Okay, now I have some test values. Let's test to make sure this math works. Again, probably feeling pretty confident it does. We could run through the math and just make sure it's working as is appropriate. It is. You know, I could do m, so 2 times -5 minus -1, so that should be -4. And then -4 plus, times 2, so -8, plus -3, so -11. My calculations are correct. I don't know why I made that math so hard for you. Sorry about that. But in the end, that's true. You just go through and you check to make sure it's working. Here again, very simple math, so not too bad. The next thing I asked you to do, though, was to return a data frame. Not just y. I wanted you to calculate y, but I wanted you to return a data frame. Let's come back to these defaults. This is something that you describe in the argument section. Okay, so return a data frame describing x, y, slope, c, and b. So basically everything is as normal except that the slope is going to be named slope and not m. So it's easy enough to make a data frame. There's a couple ways I could do this. I could just start off with a single column. So if I do that, I just have a single column called x. I could then assign new columns. So I could say y is y. I could say slope is coming from m. I could say c is coming from c. I could say b is coming from b. And after that runs, I made each of those columns in turn. The order would matter. The name is what I put over here, and the value is what I put over here. Alternatively, in what you see if you go look down in my answer key, is I just did all of that from the data frame function itself. And what that looks like is something very similar, except I could just say x, y, slope is from m, and then c and b. And what it does when it does that is it just makes the column names from the values object names. And where I did name it, it replaces that object's name with the argument name. So either method works. Either method is perfectly valid. This way is probably technically slightly faster, both for writing the code and for running. But oftentimes I like using the $sign tool because oftentimes I'm not entirely sure what's going to go in that data frame until I've played with the code a little bit and I kind of work it out as part of my process. But I think, it's different situations that you just have to kind of customize for. Okay, so at this point, I have my code, my output looks good, and I'm ready to kind of stick it into a function. So to do that, I'm just going to open up that curly brace, add it down here, give myself a nice indentation, and then manually tell R what to return as my output. I can then test the code just to make sure it's working as appropriate. X, let's just do -2 to 2. Slope of 1, 2, 3. And a C of 5, 4, I guess, and a B of 5. Now, that's actually not true. I said a lot of words that are not correct. So let's just backtrack there. The X here is -2 through 2. The C is actually 3, the slope is 4, and the B is 5. And that's because the order of your arguments is determined in this section of the code. So I just was saying it wrong because I was thinking of the data frames order as I was speaking. But these are the order of the arguments. Now, obviously, it's always easier just to name your arguments to make sure, but we can rely on order. It's just you have to think a little bit deeper. Okay, so I'm almost done. The only thing is I did say that the default should result in x equals y. And so if I look at this math, then that would mean that m would need to be 1, c would need to be 0, and b would need to be 0 by default. And so defaults are where we are kind of establishing what is this object going to be, or what is this argument going to be if it's not set by the user. I also say that x doesn't need a default value. And that makes sense, right? Like, what would you make it? I guess maybe 1 or 0, but then like, why? Like, what's the point of making that default? It may depend. Like, there's certainly uses for that, but most of the time you're wanting to predict for a certain range of x values, and so that's what I've done. X is y because of math and those default values. So my function's looking really good, but here's the final and super important step: clearing my environment, rerunning the function, and probably, you know what, specifically deleting those test data. I don't want them to distract me in the future or cause confusion. I don't want them there anymore. They were just for me to help me write the code. Now when I run that, I see my output. That's all looking good. If I start to add some new values, they're going in as is appropriate. So that went to my C value. I could overwrite my slope if I wanted to. So now I have 2x equals y. Now I have x minus 1 times 2. And I could just keep playing with it. In the end, I gave you a bunch of test code. So we can see that right now, this was output. It's been stored inside of this object. So if I just call the name of that object, I see its output. I can use it as part of a plot, although I have to make my plot pane bigger for that to work. Right now, my figure margins are too large, so it just can't plot it. But there we go. Nice little linear regression. Next thing, I have another one that's going to, if I use the return function correctly, it's going to print this output, which since I did use the return function, it printed. Had I not used return, so if I had just ended my code here, this would just run. Now, interestingly enough, I can still pull the data out, but it doesn't print by default, and that's because I don't tell explicitly R to return it. Here, I explicitly tell the function to like assign an output, and there's some like under the hood rules that, much like the arguments, if you don't really specify what should come out, the R looks through some rules and it determines what to output. It is sometimes confusing, especially when you have a lot of things going on. And so my recommendation is to always use return. At least for my class, I ask you to always use return. Finally, here, and this was just me having fun, if instead of a constant b, if I provide a changing b, I can get a weird not linear regression. So I get this weird little wiggle because my b is kind of cyclically getting larger and smaller as it progresses. So no longer a linear regression, but kind of a cool function, I think. Okay, this next one, it says the name of the function is diffmax. Make this a little bit bigger. The name of the function is diffmax. It should calculate the difference in value between adjacent positions in some data. So for example, if I have 9, here, if I, is my cursor on the right screen? Yeah. So here, adjacent positions, so 2 minus 1, that should have a difference of 1. 3 minus 2 should have a difference of 1. 4 minus 3, a difference of 1. 6 minus 4, a difference of 2. And then returns the positions between which the difference is maximum. So the positions here being 4 and at positions 4 and 5, which the 5 is the value 6, which those have the largest difference. So I hope students who were in class for this, you realize that this is essentially how you would solve that gap problem from, what was that, week 3 homework mathematically, which a lot of students are often wanting to do, but they're not quite sure how to do it. I think this is actually straightforward. You can just extract these values in a way that allows you then to subtract adjacent positions. And so, for example, if I just kind of drop that first value, and I drop the last value, so that was position 7. Let's visualize that before I do it. Yep, so here I've dropped those 2 different values. So now if I subtract this if I subtract this from this, I get 1, 1, 1, 2, 1, and 1. So then I can do some stuff to try and track this down. So let's start to write that as a function a little bit. So if I'm imagining my inputs, my input would be like, well, we could just use this math or this copy code right here. So if I am trying to figure out how to drop those, the negative positions are definitely the easiest way. So let's just say no first. And then let's do like a no last. And since I want it to be flexible, I could manually count how long x is, but if I want x to be able to change easily, then I would need to measure x in some way. Nope, got to run x. Ow! And let's check to make sure we did this right. And again, always do this step, like always be checking. That's kind of your big goal here, is just always be checking your maths. That's the beauty of the coding, is you can predict and then check. Instant gratification science. Okay, now that I've done this, I can see my differences. Let's just assign that to an object. So I'll just call it adjacent diffs. And it's funny to me because I'm using the word diff. It turns out that basically everything I just did is also a function called diff. So if I had just called diff of x, it went through that entire process precisely. So that's fine, either way. Additionally, I could have written this by doing something like 2 through length of x instead of just dropping the negative x. And similarly, I could have done this as 1 through, I'm going to use parentheses here, the length of x minus 1. Although I think we can all agree that the method I first showed was the simpler method. Because I tend not to use negatives, I do actually typically do it this way. And I honestly don't really have a good reason for that. I just think I tend to avoid negative values because I just find them a little bit confusing in these extractions. But this does work, and this is certainly a cleaner piece of code. Although the cleanest is just to use the diff function, which is purpose-built for that. So either way. Anyways, I now have those differences. So it's called adjacent diffs. If I visualize it, those values are stored inside. I'm ready to move forward. Okay, what am I going to do with these differences? Return the position between which the difference is maximum. Now, unfortunately, there's two values here which are at the maximum value. But I say, if there is a tie between the differences, pick the first one. And there is a lot of ways to do this. There is explicitly a function called which.max, which does this. It pulls out the position, which is maximum, and in case of a tie, it pulls out the first one. But we can also just do this manually. To determine the maximum, it's fairly easy. It's just the max function. And to then check to see is the value the maximum value, I can just do equals adjacent diffs. Now I can split those into two separate steps, but in the end, like this is saying, I don't know, max logic. I think that's easy enough name to understand. So true or false, is it the maximum value? Now the reason I would want to do that is because it's kind of hard to work with those logic. And so I can turn those into the positions using which, and then I can pull out the first of those whiches using an extraction. So there we go. There's the position of the first max. So call that max position. And we'll call it 1, I guess. Max pos 1. Okay, and just testing it. Looks like it's stored in 4. That's perfect. So 4 occurring 1, 2, 3, 4, and that means the other position I'm wanting is that value plus 1. And so I could combine those. Sorry, this is just my output. It should return the positions, so plural, between which the difference is maximum. So it should be this position and this position. And please note, I do say I want the positions, not the values themselves. So I'm just going to call this out. And there we go. I've puzzled out the inside code of my function. Now, everything I just did here could also be done using a function called which.max, which just does what I've just shown. That's it. But again, there's no reason I need that. That makes it cleaner and easier to read, much like replacing this with diff makes that easier and cleaner to read. But in the end, like, it's all doable. It's just simplification or not. Okay, so now we need to figure out how to put this into a function. Well, my input's pretty clear, I think. It's going to be that x argument is my input. Give this all a nice little indentation. So I'm going to hold Control, Shift, and then press A. And R helped me adjust all my formatting. And then finally, I'm going to return out and name my function. So did I say what to call it? Diffmax. All right. And I'm actually pretty much done. I just need to test things. So let's do that. So I'm going to get rid of all these intermediate objects. I have diffmax now. And instead of making an object called x, since I am using an object called x on the inside, as I test my function, I'm just going to add it in directly. So this is not me making an object. I won't end up with an object called x on the outside. That's working. I get 1, 2, 3, 4, and 5. So positions 4 and 5 are correct. And so if I just called that test deck instead, notice I'm using a name that's different on the outside than was on the inside. if I wanted to use those positions to investigate test_vec itself, I could use that as part of an extraction, and now I can see the values that were stored inside. Obviously, I could separate those into different steps. So max positions, positions, sorry, positions. I could then use that as part of an extraction as well. So everything really does seem to be testing out well. If I just run this by itself, it is printing. That's because I'm using that return function. Everything looks really good. So I could go through my other examples. Yep, looking great. Here is the depth df. This is me just demonstrating that, yes, indeed, I can use it to calculate that gap in positions. Ooh, look at that jump. All right, next function. This next one is just basically take all of that for loop and place it into a function. So that's easy enough. I'm not going to copy that. Oh no, I forgot I messed it up, didn't I? We'll fix it real quick. So what I'm looking at is I'm just looking for any unmatched curly braces. This is partially why I really like to use these rainbow colorings, because it allows me to quickly find where I have stuff missing. It's also why you'll notice that I do a lot of organization. So I make sure that everything's indented well, and when I mess it up, so let me just mess it up, I do things like select it and then press Control-Shift-A, and R will help me format it. I don't always like how it formats it, but it definitely helps, especially when it's gotten a little bit chaotic. Okay, I'm going to copy that now. Still got my computer. We'll come on down. There we go. Somewhere, I guess I erased your code goes here. So I'm going to place this into a function. So I'm just going to highlight everything and shift it over. And we'll start the function at the top. We'll call this RPS fun function. Open curly brace, and the player will be our input. So just testing it by itself, okay, so it's working well so far. Okay, yep. All my tests looking good so far. So now let's go see how we can, how I needed you to change it. So I wanted you to change the print message or print functions to message. This keyboard's got a broken control button. So I'm just gonna have to scroll through this with my, yeah, there we go. Done. You should have that at least the print. So your code should print off at least the response text. So I'm going to add some printing. Print responses. So print player. And a lot of students will just try to do this, which you think would be nice. Well, I got to make a player object so I can test this code. Rock. Right. So what it's saying is that it just can't quite figure it out. It's because it's trying to use this player object as something not the stuff it's going to print. If you want a print function, to combine stuff, the paste 0 function is probably your best way to do this. Additionally, we could, instead of using print, we could use message. Now I know in my instructions I said print. It's because I tend to think of them fairly synonymously. They're not synonymous, but I do tend to think of them fairly synonymously. So this, I think, looks better, so I'm just going to use the message. But the paste 0 would have worked as well, but I would have needed to, for the print, I would have needed to use paste 0. Computer. Okay, and now I think I'm fulfilling this, at least if I assume that by print I meant message. Optional, added code to print the player and computer responses. Yep, that's what I just did. Add code to return 0 if the player won, 1 if the player won, 0 if the player lost, 1 if the player won, and 0.5 if it's a tie. So in this situation, it's a tie. And so then we would return 0.5. And this is actually going to exit the code here. So even if there was something later on, it would print a message. So here the player lost, so that's a 0. Here the player won, so that's a 1. Here, this is a stop message. Error. Should have been here. Here the player won. Here the player lost. And here something's gone wrong. Error. I'm going to stop making that horrible sound. This is going to repeat one more time. Great video, I know. Very exciting, dynamic. I guess I could narrate to you. I covered rock, paper. Wait, I just said random words. But player lost. See, I got my head, so I can't do it. And I have to just go back to saying weird stuff. I already did a stop message here. And finally, this is probably a warning message here. You made a typo. Try again. There we go. So I get my little snarky message, and then I get this warning message. So it still completes. I shouldn't ever see the stop unless I messed up with my code in here, which I haven't currently. I don't believe, at least. It's definitely possible. But yeah, so I mean, this is all looking good. Really, the last step is to clear my environment and just test it one more time, running that function. And you'll note I'm just putting it on the in curly brace and running it without highlighting anything. And when I do that, it does connect all of these curly braces together, and like it runs the whole piece of code. Because at its core, this is just a lot of text being stored inside of an object. So it's code stored inside of an object. That's what a function object is. So when I ran this, I'm effectively running one giant piece of code that's spread across multiple lines. But if I test it out and I give a value that is reasonable, I'm getting my output. Yep, it's all looking good. It's returning values as is appropriate. Here I'm demonstrating that I can control this random number generation. So every time I run this, it turns out that even though they're nested inside the function, that the set.seed does still apply to that next random function, which is that sample function. I did have a lovely question from a student who asked, how would you know that? And the answer was I would have been like, maybe, and then tried it, and it would turn out that yes, indeed, it does work this way. But I certainly wouldn't have known that with any level of confidence. This is just, the beauty of coding, is that you can test it yourself. You can answer your own questions. It's lovely. So anyways, this is all working. I'm going to skip past the rest of my checks because I think it's all working. The big thing here is this should return a stop message. Oh, I said I wanted it to return a stop, and so that way this value wouldn't have been made. However, I used a warning instead of a stop. So what ends up happening is my warning ended up being used for this returned value since I didn't actually return anything in the code. Oh, no, I did return it. I specifically returned this. That's right. Sorry, I forgot. Anyways, that's it. Done. Actually, I don't think I returned it. Yeah. So this is where I was saying before that it turns out that R often, like, even if you don't use return, R often will return something. Predicting what that something will be can be a bit tricky. So apparently it will return my warning message. I think I would have guessed that if it was at the end, but I definitely wouldn't have known that. All right, next up, we are writing a simple loop. This one's going to be very simple. I could do this in one line of code, no problem. We are going to spread it out, though, because we're going to show some good practice. So we're going to call this for cur seed in 1 through, what did I say to do? Repeat this 10 times, set the seed using 5 times the current round of the loop. So set.seed is the function. Whenever I run this, cur seed will be changing from, I have to put that in there, cur seed will be changing from each value in whatever is over here to the right. Now, I could put the colon here, and I often do, but I also could have put it out here. I could have called it, I often will call this like loopvec for just loop vector. And so, I mean, this is saying the same thing, right? Every time it runs this, it's going to set the seed, and I said to multiply that by 5, and then do the code right here. Okay, so when I run this, it's run each time, and because I was setting the seed, that should match all of this precisely, or at least precisely enough outside of, I used a few different messages because we just, improvised that earlier. But yeah, that all worked. In the end, the way the for loop is working here is it is going to use this to control how many times it loops, and every time it loops, it's going to change this. It's going to create this, first of all, and it's going to change it to each of the different values. So the first time this will be 1, then it will be 2, and then 3, and then 4, and then 5, and then 6, and then 7, 8, 9, and 10. And if I wanted those messages to print out in the opposite order, I could do the seed backwards, and now it's just going the opposite direction, interestingly enough. Okay, and I think that's the last one. Yeah, all right, done. How long was that? 42 minutes, lovely. All right, hopefully that helped. Just, have some fun with it. You can do this on your own. Basically anything we've done, you can turn into your own function. I got into this while just making scripts for myself and my research. A lot of students do ask me, like, how do you learn this? And it's just a practice. Like, for me, it was practice coupled with purpose. So I needed some sort of motivation, and these were what was needed. And so I got better at it because of that. And I think that's very realistic. But that's kind of what your homeworks are for. But, if you want to, you can just give it a day and come back to these and try them again. Go back to that standard deviation, go pick a genetics model and try to write that. Like I've shown you that Hardy-Weinberg. I had a video on that one a while back. I had those timer videos. Just pick yourself a problem and go with it. But practice. That's how you learn this skill. It's just a different way of thinking. All right. I think with that, I'm going to end the video. Have a lovely day.